Hi, good morning. In the last session, we have explored the different storage classes. We have explored two important keyboards, auto and static. Can you recall what is auto and what is static? When do we use static keyboard and when do we use the auto keyboard? Anyone? Vishal Ram, Manasa, we have used the auto keyboard for the automatic storage class. So by default, the storage class comes under the category of automatic one. Auto, right? The keyboard is an optional one, right? By default, not necessary because the memory allocation or storage is done at the stack space by default. With respect to auto, we have explored its scope is defined within the block of code and its lifetime is also within the same block. By default, int x or int I, that is same as auto into I, auto into x. Auto is a keyboard. Second one, static storage class. Static is concerned in between the different function calls. We need to retain the value of the static variable. So its scope is defined right only within the block of code, but its lifetime is it retains the value during the function calls. That means lifetime is within the program, within the entire program. The program is running, right? Until the program finishes its execution, the static variable retains its lost value or retains its updated value. That's what in the last example we have explored the usage of static keyboard. Static int count is equal to 10. The first function called initial value of static, right? Count, this is set to 10. Then count plus plus that increments the value of count by 1. Count becomes 11 in the first call. So when I is equal to 2, static int count is equal to 10. This initialization is not permitted. Second, third, fourth, etc. So previous value is retained. Count plus plus. Then count becomes 12, then 13, 14. So this way, in each call, the value of a static variable count is retained from the previous value. That is the advantage of static keyboard. So its lifetime is concerned, right? So within the program, until the program finishes its execution, the value of the static variable remains the same. That means it retains the value of the previous one. Understand or not? Have any doubts in static as well as auto storage classes? Static, right, where the variable is going to be stored means in the corresponding data segments, the variables are going to be stored so that their value are retained, right, during the execution of the program. You need to think of, right, what will be the initial value of the static as well as the automatic variables. For example, let us check the next example, finding the initial value of auto and static variables. Particular two variables and check it. Hash includes stdio.h int main have two variables auto into A, static into B, print their values, printf slash n, A is equal to percentage D, B is equal to percentage D, comma A, comma B. And if you update, right, for example, A is equal to 100, B is equal to B plus 1, then print the updated values, print slash n, A is equal to percentage D, B is equal to percentage D, comma A, comma B. Then at the end, return 0. Save the file save, file CP65, okay, F9, no compile time errors. By default, automatic variables are assigned some garbage values, and by default, static variables are assigned the value, right, 0, right? Let's check it. Control F9. Initially, right, A is 3172. This is one garbage value. Static into B. B is initialized to 0. Then A is updated to 100. B becomes B plus 1. B becomes 1. In case if you run the second time, control F9, right, you may get, right, different values because every time some garbage value is going to be stored in the variable A. In different compilers, right, try to check it, you will get different outputs. So here A, right, garbage value is stored in the variable A, where static into B, right, this sets 0 to the variable B. In case if it is a character 1, right, you can have some default value. For example, static and ch. Here let us print the value of ch. Ch is equal to percentage B or percentage C. Here put a value ch. Here set a value ch. Ch is equal to x. You can add D is equal to percentage D, C is equal to percentage C, ch. A comma B comma ch. Let us check its initial value. Initially, right, ch is equal to something, right? This is a blank space. Then ch is equal to x. To find out the exact value, here you can use percentage D format. Put again ch comma ch. Control F9. What happens? Ch, right? This is a blank space, right? Then nothing, right? The value 0 is stored, integer equivalent. 0 is stored. Then updated value of ch is x. So by default, if it is the numeric type, all static variables are initialized with the value 0, and the automatic variables are assigned some garbage values. As far as their scope and lifetime are concerned, automatic variable scope is defined within the function definition, and their lifetime is also within the function definition. Static scope is concerned, static variables can be accessible only within the defined function. Outside the function, static variables cannot be accessible, similar to automatic variables. But their lifetime is until the program finishes its execution. That means in the main function we have defined the variable static into B. the value of B is retained. Its lifetime is right until the program completes its execution. So wherever you want, you can access the value of the static variable. Static variables are retaining their values even in different function calls. Hope you have understood the logic of automatic as well as static variables.
Sir,
Have any doubts? Yes.
sir, but in the yesterday's class, while using the auto keyword, it doesn't show the garbage value, right? What is difference between this and that, sir?
In the yesterday session, we have initialized some values. Suppose in the A is equal to 10. Then it shows the initial value of A as 10. If you miss to initialize the value, by default some garbage value is assigned. Normally, right, if you put int A semicolon, try to print a value of A, different compilers, we can observe that different values will be stored. Those values are set to be garbage values. Understand?
Okay, sir.
Okay, the next keyword is register keyword. Register keyword. We'll be studying the computer architecture paper right in the next semester. So there, right, you will learn different types of registers available in the CPU. So whenever we need to store a variable in terms of a register, in case when there is a space that is possible in the C language, there we need to use the keyword register. For example, variables may be declared using register keyword. In this example, let us declare a variable using the register keyword. Register, after I type register, the word, right, this is highlighted. This indicates that register is the keyword. Register, for example, I write int q is equal to 100. Only difference is normally int q is equal to 100 means the variable q is placed in the corresponding stack. Or static int q is equal to 100 means the variable q is placed in the corresponding data segment, that is a storage. As far as the register is concerned, the variable q is going to be stored in the system register so that wherever you want to access the value of a variable, we can easily access it. Only advantage is the quick access. That's all. Otherwise, you need to extract the value of the variables from the system memory. That takes a time-consuming process. To have a faster access, you can have the register keyword. You will not find out any significant difference, right, when you run the program. So just to have a concept, register, this is the keyword which is used to declare or define the variables so that its storage is stored in or storage is occurring in the corresponding system registers. With respect to scope and lifetime is concerned, register variables are similar to automatic variables. Scope is defined only within the function, opening and closing curly braces. So outside this scope, you cannot access a variable q. Lifetime is also limited with respect to the defined function. Outside the function, right, or when the control comes out of the function, value of the variable q is lost. This can be compared with the static storage class. There, even when the control comes out of the function, the value of the variable is retained, right? Value of the variable remains whatever that has been updated finally. So in the different function calls, we have realized that the value of count is taken from the previous call. That means static is concerned, lifetime is within the program execution. Here, register is same as automatic storage class. Only difference is the values of variables are simply the variables are stored in the system memory just to have the quick access, fast access, and have this kind of register variables. We can define the variables the register. The next one is external keyboard. External variables. External keyword. The keyword extern is used to define the external storage class. That means the variables may be stored right somewhere in another files or another block of code, so that external variables may be reused in some other C++ or other C programs. For example, here I do like to define some external variables. Extern into A is equal to 1. Extern float P is equal to 1.2. Extern and CH is equal to say E. These are simply external variables. That means these are external declarations. External declarations. We need to store our this file right in some name right with the extension H. Carefully see, I save a file. For example, file save external variables dot h. External variables dot h. Now external variables dot h. This is a file. In this file, we have three definitions of external variables, say A, B, and CH, which are of integer, floating point, and character type. Now we can create another file, for example, some test.c, in which we can access these variables A, B, and CH. For that, what we have to do, for example, I create another file. In this, access the external variables. Find in external variables dot h. Since the file is right, what is the file? I think external variables file open. External variables. What is the file name? What we have given there? External variables dot h. Okay. External variables dot h. Now let us include that file. Hash include stdio dot h. Hash include The file name is extern variables dot h. Extern variables dot h. That is defined as a header file in which some external variables are defined. We do like to access those external variables in the current program by including this header file. Let us test by writing a main function. Here, access the external variables, printf slash n is equal to what are our external variables? A, B, and CH. Okay, A is equal to the percentage B, then B is equal to percentage F, CH is equal to percentage C, comma A, comma B, comma CH. Now I save this file, save as CP67, compiling the file, control F9, A is 1, P is 1.2, and CH is E. Suppose here I update CH is equal to F, file, save, then recompiling the program, control F9. Now what happens? CH is updated to F, so that in the output we can see CH is equal to F. So what is extern? Extern, this defines a storage class like static. Here the variables are going to be stored in some data segments. Once the variables are stored, the variables can be accessed somewhere in another program because of its nature, external variables. Its scope is concerned. What is their scope? That is important. To understand the scope, have a look into these code. In this, we have included the header file extern variables.h. Since extern variables.h, this is the actual file which declares the variables. Wherever we include the header file extern variables.h, its scope is accessible. That means extern variables.h, external variables are accessible. Wherever in the C program, there we included a header file external variables.h. For example, have a look into this. First, I have commented this line hash include external variables.h. Pressing control F9. What happens? Compile time errors are reported. Undefined variable A in function main. Undefined variable B in function main. Undefined symbol, right? CH in function main. Because A, B, CH, these are undefined here. So clearly its scope is wherever we have included the external variables.h header file, there we can access the corresponding external variables. So its scope is with respect to the multi-file way, one file into another file. One file contains variables that can be accessible within the function definition or within the main function or within the user defined function we can access the value of external variables. Now try to understand here. I do like to change the value of external. Before that, right? Before changing, have a look into this one. External into A file save. The variable A is defined as the external variable. Its type is integer one. File save, but the variable A is not initialized. Now what happens? Control F9 into this error message. Undefined symbol A in module. What happens? The variable A is not suppose float B F2 F2 again compile this code F9 two compile time errors because undefined symbol A undefined symbol B. So clearly understand that variables, external variables, wherever we declare, you need to provide the initialization that is required. If not, here if we try to access or initialize A is equal to 10, E is equal to 20, F2, F9, again right what happens? Compile time errors are the result. This initialization are also not permitted here because the variables A and B are external variables. In case here, if we redeclare A and B as external into A, external, go to B. Now have a look into this segment. What happens? Undefined symbol A, undefined symbol B. Here also, we need some initialization. A is equal to 10, B is equal to 20, F2, F9. This is matching with the variable that has already been included in this one. So here provide initialization into A is equal to 1, B is equal to 2. Then try to run the code again. F2, F9. This results in compile time errors. So clearly understand that wherever you want to define external variable file name dot h header file, the variables must be initialized. Only those variables are going to be accessible in the corresponding file, say external file, and we are included the corresponding external variable file as a header file. This is a solution. So all external variables must be initialized during their declaration. Have any doubts in this? Have any doubts? So in case, right, whenever you want to have some set of variables which are assigned some initial values, in case if you want to access those values somewhere in other files, other programs, simply right make those variables as external variables, and these variables can be reused in some other programs. That is the logic of a multi-file program. We can access or you can include any number of external variables in a particular program. For example, here we have defined only one or included one external variables dot touch header file. In case if you have several external variables dot touch, several header files, those header files can be included in this program. So all those variables can be accessible here. But its lifetime is concerned, right? Only within this opening and closing curly braces. The variables A, B, and CH can have their values. So second, right, as I said earlier, here if I write having the same printf statement, edit, copy, edit, paste, file, save, F9. What happens? F9, undefined string, CH is equal to C, closing single quota, F9, no errors, control F9. It's compiling, right? Some other program, file, okay. Let us close some other programs, file, open. Now it's fine. Initial values of A, B, and CH are 1, 2, and F. After their update, A is updated to 9, B updates to 8, and CH is updating to the character C. That means even though right A, B, CH are external variables which are defined in the previous file, external variables dot fetch. Here we can modify the value of external variables if required. Control F9. Process is already running. Control F9. A is controlled. So wherever you want the update, you can update the value of external variables in the required file. Have any doubts? Have any doubts in the external variables? We can also have the external variables, right? The same file. For example, have a look into this one. Next to file. Here we have two files, external variables.h, and the file that included external variables.h, say CP67. In case if you want to have the external variable, the same program, that's also possible. External example include stdio.h, external int c, int main, return 0. Here we do like to print the value of c, print hash n print slash n c is equal to percentage d comma c. Let us see right how it executes. File save CP68. During the compilation stage, as usual, external variables require the proper initialization. linker error undefined symbol C in module CP68.cpp, because here extern into C, this requires the initialization. Suppose C is 100, control F9. Now what happens? Extern into C is equal to 100. Here, the variable, extern variable is declared before the main function. This is just similar to the global variables concept. C is equal to 100, right? That is a global variable. Here, we can access the value of C, the C as 2, printing the value of C as first. The value C is 100 is printed. Then we have updated a value C as 2. So C is equal to 2 is printed. Here, extern into C is equal to 100. This is same as into C is equal to 100. Only difference is, previously we have two different files. Variables are declared, right, in a better way using the extern keyword. In case in that file, if you miss the extern keyword having that initialization, that variable cannot be externally accessible in the required file. So extern data type variable is equal to value, that is completely required here. This means the variable C can be externally defined and it can be accessible anywhere within the program. Extern into C is equal to 100. Further, if you redeclare extern into C here, what happens? This is accessible into C is equal to 125. Control F9. This results in the compile time error because already extern into C is defined. Here, if you like to define only the variable extern into C, this is perfectly valid, right? You try to check it in some compilers. Again, right, if you say extern into C, this is just to tell C is the external variable that is referred from somewhere. Here, somewhere means before the main function, the variable C that is defined as the external variable is taken here. Extern into C. That's what in the next line, the value C is taken as 100. Then C is updated to 2. Then that's all. Extern into C is equal to 100. Here we have said that external variables should be declared and it should have the proper initialization. But in this example, before the main function, since we have the proper initialization, inside the main function, again, if you want to tell explicitly as C is the external variable defined before the main function, you can have this option, extern into C. Even, right, if I have commented this, control F9, even, right, you will get the same result. Control F9, you will get the same result. C is equal to 100. Then here, C is equal to 2. So simply, right, have the logic of extern keyword with respect to multiple program. Wherever we need external variables, all variables must be declared and initialized. Then the file that included the external variables can access the external variables anywhere within that program. That is possible. Even in the any of the user-defined functions, you can also access the external variables once the file is properly included. Second thing, external variables are right similar to the global variables. Previously we have seen. Just to have a look into this one, I removed the keyboard external. Have a look into the output. Output remains the same, right? Similar to putting extern into C is equal to 100. Because here, what happens? By default, C is right the external as well as a global variable. So if we need explicitly, we can use the external keyword before the main function section. And additionally, right, to tell C is referred externally that has been initialized before the main function section. You must use or you can use external into C here. There will be no effect. But if I comment on the global external declaration, now what happens? Ultimately, external into C. C is the external variable that is not initialized. So this requires the linker error, right? Compilation error. So please understand the purpose of external for a better way to access the variables from one file into another file, one program into another program. Accessing the files in multi-files, multi-file programs, we can use the logic of external keyboard. In the same file, if you try to use, you try to follow this type, same thing. So scope is consequent, right? Into C is equal to 100, this is made as external variable. This variable can be accessible anywhere within the program. For example, here, I do like to define the function void list. Here, we are printing the value of C. Printf slash n is equal to percentage it comma C. Have to include the prototype void is have to F9 good compile time errors control F9 we need to call a function. So at the end we try to call a test function F9 control F9. What happened? C is equal to 100. C is updated to 2. C is equal to 2 is printed. When we called a test function, here test, the value of C, final value of C, right, or updated value of C, as 2 is taken. In case, if we comment on this C is equal to 2, now what happens? Control F9. Since the initializer, global initializer, 100 is there, 100 is accessible in all the functions. Main function also access the value C as 100. Test function also access the value C as 100 because here now C is taken as external as well as a global variable can be accessible anywhere here. But once you change the value of external variable here, C is equal to 2, then after calling the test function, what happened? The final value of external, control F9, CS2 or 2 has been taken, right, even inside the test function. Let us check, right, in a different way. Let us update C to 50 and try to print the value C here after the function call. Printf slash n C is equal to percentage it comma C. Control F9. Hope you understand. Initially C is 100. So in the main function C is 100 is printed. Then the external variable C is updated to 2. C is equal to 2 is printed. Then inside the test, C is accessible. So what is the scope of external variable? The scope is here, previously, right, we have said, within the main function. Now we have added one user-defined function called test. We have not declared the variable C here, right? So the variable C is externally taken here. C is externally taken here, but the external variable C is previously updated to 2. So that updated value C is equal to 2 is taken. Then external variable C is updated to 50. Once the control comes back to the main function, printing the value of C at the end, the updated value 50 is taken. So 100 to 250. Here, as we discussed earlier, if you want, you can have this unnecessary external declaration. Extern into C, I make it in a comment, right? This is to inform. C is again the external variable, right? But this is not necessary. By default, into C, right? This is made as external variable. So, and we conclude its scope. That's the scope of external variable within the program. Scope is within the program. Hope you understand. Into C, right? This is the external variable. The main function we have access to the variable C, right? Even this external into C not necessary. In the function definition, sorry, the function definition here we have access to the variable C without any of its declaration. So scope where we can access the variable external. Accessibility. The accessibility is provided anywhere within the same program, anywhere within the program where the external variable is defined or external variables are defined. Second, lifetime, longevity. Lifetime is until the complete or within the program, we can say, right? Or we can simply say lifetime is defined within the program. That means until the completion of execution of the program. So here, void test C is equal to 50. Please understand, the C is an external variable. C can be accessible anywhere within the program. That is the scope, anywhere within the program. Lifetime until the program finishes its execution or until the completion of the execution of the program. Yes, the external variable C is accessible. C is 50. We have tried to print the value of C, the main function. At the end, we have got at the end of a main function, the value of C is 50. That is a purpose, right? Our scope and lifetime of the external variables. Have any doubts in the storage class?
Sir, if we didn't use external variable, will the C value be accessed in the main function?
Okay. It's external declaration here. I comment external here. Into C is equal to 100. Because here we can see the different effect. First, int C is equal to 100. C is a global variable, but C is not external variable. The effect is here. Let me comment on this external into C also. Now into C is equal to 100. Here we are trying to print the value of C. So we can expect the C is 100 first. File close. Okay, control F9. You can see CS100. Then void distant int main. Here C is 100 is printed. Then C is equal to 2. What happened? C is equal to 2 is printed. Then we have called a test function. In the test function, first we have printed the value of C. C is equal to 2. C is equal to 2, that is printed. Then C is updated to 50. After calling test, printing the value of C, the variable C is also updated to 50, right, in a strange way. So here, you need to conclude this into C is equal to 100. By default, extern into C is equal to 100. By default, that's what I said earlier. External variables are essentially the global variables. Unexpectedly or unnecessarily, right, we have provided external keyword. You keep into C is equal to 100. The same way, right, here you cannot expect it. After the return of test, print C, the last printf statement is not printed the value of C as 2, because here C is 2 is initialized here. This does not mean the value of C is 2 completely within the main function. Who is C? C is a global variable which is of integer type, for example. So wherever you want to modify the value of the global variable, that will be reflected in other functions also. So by default, this into C is equal to 100. This is saved as only thing is here the external variables are defined, same program, but in case if these variables are defined as separate header files, then these variables can be reused, right, utilized, right, again in some other C programs. That is the logic of this one, external variables. So as we discussed earlier, scope is defined with respect to the program. We can access the external variables anywhere within the program. Lifetime is defined until the program completes its execution. The external variables are retaining their values. But this is compared with the static keyword. The static keyword, right? The variables can be accessible only within the defined scope. Here, external scope is defined with respect to the complete program. That's the difference between static to external. So hope you understand the different storage classes: auto, static, register, and external. Have any doubts? If you have any doubts, now you can ask. So far, we have explored the control statements, conditional control statements, unconditional control statements. Then we have explored functions, how to define functions in a different way. Then defining the functions recursively, how a function can call itself as a recursive function. We have considered the two important things: recurrence relation and a termination condition, one or more termination conditions, and a proper recurrence relation, actual parameter, update of formal parameter, then change in new actual parameter, so that in one stage a recursion should terminate. And we have discussed several examples of functions as well as recursive applications. Then finally, we have discussed the four different storage classes: auto, static, external, register. Simply, these storage classes are focusing on how the variables are stored and how the variables are accessed, how long the variables are retaining their values, their scope and accessibility, scope, accessibility and lifetime. These are the things that we have explored so far. Next, we need to focus on the concept of arrays. Arrays are homogeneous collection of variables. As we have seen earlier, if you like to have the marks for 100 students in single subject, we need to have the variables, say into mark 1, into mark 2, into mark 3, etc., into mark 100, to represent the mark in a particular subject for 100 students. Instead of having those declaration, we can have the simplified declaration as int marks of 100. So that marks, this is the name of the array, 100 that it defines the size of the array. 100 memory locations will be allocated to the array name, say marks. So that conveniently we can access the indices, subscripts, 0, 1, 2, 3, etc. up to 99. So marks of 0, marks of 1, marks of 2, etc. marks of 99. Conveniently we can access any of these 100 memory locations. Even we can fix some other memory locations beyond the range 0 to 99. If you fix some indices or index values, then when it exceeds the size of the array, when the count exceeds the size of the array, you are not allowed to use any other indices that are defined and informed to the compiler. So we will see further, what is an array, how to declare an array, how to initialize the array elements, and the types of the array: one-dimensional array, two-dimensional array, or multi-dimensional array, how the array elements are going to be traversed, forward direction, reverse direction. Then how to define the two-dimensional, that is a multi-dimensional array, to store, for example, the matrices having n rows and m columns. How to represent the array of elements to store the matrices and basic matrices operations: addition, subtraction, multiplication, transpose. And we will focus on next strings, array of characters, not only for the numeric types. Arrays can also be defined for the character types, character ch of 100. 100 characters can be stored in the array ch of 0, ch of 1, etc., ch of 99. Then we can process the strings or character arrays. We can perform the manipulations of strings. We can check if the given string is the substring of the original string, or we can find the occurrence where the given pattern is available completely in the given text array of characters. We can perform string manipulation, string operations using arrays. So arrays, as an important topic, we need to explore further how to define one-dimensional, two-dimensional, multi-dimensional arrays, and how to process how to access the array elements, two-dimensional or even one-dimensional arrays. So in the next session, we will focus on the concept of arrays and types of arrays. Have any doubts? If you have any doubts, now you can ask. Okay, please go through this session again. We will discuss arrays in the next session. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.